Hello everyone, myself Dr. Saswat Kumar Mohanty, and in this video I'm going to discuss few questions on previous questions on NEET Biology. So coming to the first questions. Here we have two statements. Statement 1 it states that a protein is imagined as a line. The left end, the left end represented by first amino acid, which is your C terminal end, and the right end represented by last amino acid. Okay, right end and last amino acid, which is N terminal point end. Okay, statement two is represents that adult hemoglobin it consists of four subunit. Out of the four subunit, two are alpha type and two are beta type. So, in the light of the above statement, choose the correct answer from the options given below. So, option A, both 1 and 2 are false. Option B, both 1 and 2 are true. Option C, statement 1 is true but statement 2 is false. Option D, statement 1 is false but statement 2 is true. Okay, let's discuss about this statement. Okay, first let's discuss on the statement 1. Statement 1 states that a protein is imagined as a line. Here is mentioned about the structure of a protein. So what is a protein? Protein are the long chain of amino acids. Okay, I can write AA for amino acids, long chain of amino acid connected by polypeptide chain, or you can say this linkage. They connected by peptide linkage. So if there is more number of peptide chain, it is called as long chain of amino acids connected by polypeptide chain. So we can imagine it as a straight line of amino acid. If you say this amino acids, so this will be your what? Start point, and this will be your end point, and the left side is start point and the right side can be end point. So here he mentioned that this left side is represented by first amino acid. Yes, because this is the start point. It is represented by first amino acid, and the right side is end side, and it is represented by your last amino acid. So start and end last. So the main thing is that the first amino acid is mentioned as C terminal, and the last amino acid is mentioned as N terminal. So before coming to C terminal and N terminal, so here what is the structure of amino acid? You should know that. Okay, structure of amino acid is NH2CH. Here R group for different amino acid, then C double bond O and monomer O minus. Okay, so this is the N side. N terminal means this is the N side, and C terminal means C side. Because so now when the amino acids form a peptide linkage, means this side NH2 of one more amino acid. Here I can write one more amino acid or C double bond O minus. So here in the peptide linkage, the COO group, COO minus, is NH2 group of the other amino acid. They form a peptide linkage. Okay. So when they form a peptide linkage like this, more amino acid they joined by peptide linkage. COO minus group of the first previous amino acid with the NH2 group of the upcoming new amino acid. So as you see, the starting point start amino acid, maybe this is start amino acid. I can write start here. So you can see start in the start amino acid, the CO minus group was what? It was involved in the formation of peptide bond. So here the first amino acid, you can say this is the N terminal amino acid. Whereas in the last amino acid, the NH2 group was involved in the formation of peptide bond. Okay, and write this the last. Okay, so here at the end what you will get C carbon COO minus. So what the initial start point is your N terminal point, whereas the end point is your C terminal point. What he mentioned here, first point, first amino acid is C terminal and last amino acid is N terminal. Just it mentioned all statements are correct, but here this point showed that the statement 1 is a false statement. I can write statement 1 is a false statement. Okay, coming to statement 2. Statement 2 mention about hemoglobin. Hemoglobin is a multimer. Okay, four units are combined in hemoglobin by your Fe ion in between. Okay, so in hemoglobin, the four subunits they binds to four oxygen O2 O2 heme proteins are there. Okay, so here two are alpha subunit and two are beta subunit. Hence, option 2 is the correct statement. So, statement 1 is wrong and statement 2 is correct. So, what is our answer here? Our correct answer is statement 1 is false, whereas statement 2 is true. This is our correct statement. Okay, coming to the second question. And these questions also they mention two statements. Statement one, it mentioned about low temperature preserves the enzyme in a temporarily inactive state. Okay, whereas high temperature destroy enzymatic activity because protein are denatured by heat. Statement two, when the inhibitor closely resembles the substrate in its molecular structure and inhibits the activity of the enzyme. It is known as competitive inhibitor. Okay, two statements on enzyme. So let's see options are options A, both 1 and 2 are false. Option B, 1 is true but 2 is false. Option C, both 1 and 2 are true. Option D, 1 is false but 2 is true. Okay, coming to the first statement. First statement, see here, here it mention about your protein or you can say enzyme. Okay, so you know that all enzymes are protein. Okay, all enzymes are protein because means they are made up of amino acid. Get a protein. This is a what? A what folded structure or three-dimensional structure of protein which shows some enzymatic activity. Those are enzyme and means enzymes are protein. And if it is a protein, if you boiled a protein, the protein will denature. Okay, like your egg. If you boil the egg, what happens? The egg white become very hard. Means you are denaturing a protein. Okay, so when denaturing means you are breaking the structure. Denaturation means denaturation. It means you are breaking the structure, breaking the three-dimensional structure. Okay, we are breaking the three-dimensional structure. So now, if we break the structure, means what? Now protein is inactive. Now the protein is not there. See, any protein is active in their 3D structure, or you can say the folded structure in their folded form. Okay, protein folding, because like if we read, proteins are like primary structure, secondary structure, tertiary structure. Well, means what? We are doing protein folding. When a protein fold to a proper shape, then it is active. It's like enzyme are protein. When this protein are folded in a proper structure, the enzyme is in its active state. If you heat, then it will denature and protein will degrade. If protein will degrade means the enzyme activity also lost the enzyme activity. Furthermore, okay, last is the first statement, last part, because is correct. The enzyme activity, okay, in high temperature, destroy the enzyme activity because protein are denatured by heat. Okay, the first part of statement 1. Low temperature preserve the enzyme in a temporarily inactive state. Okay, statement 1. See, a protein, if you decrease this temperature, if we give a protein a low temperature, it will not degrade a protein. Remember, it will not degrade a protein. But in case of enzyme, okay, enzyme the curve temperature curve of enzyme. If you increase the temperature, this is the enzyme activity. If you increase the temperature from 0, okay, to more, the maximum enzyme activity you will find near 37 degrees Celsius. So, if we increase more in this part, because the enzyme activity is not there because all proteins are degraded. Whereas if you decrease the temperature, the enzyme activity will reduce because in low temperature the activity is less. Low temperature activity will be less. Okay, but it will not degrade the protein. So that's why you can say that it is in a temporarily inactive state. Okay, means the enzyme is in a inactive state. Once it finds a proper temperature, optimum temperature, that time it will once more it will become and comes to their active state. Okay, are you getting it? So then coming to the second statement. Means what? Statement 1 is the correct. I can write statement 1 is the correct statement. Statement 2. When the inhibitor closely resembles the substrate in its molecular structure and inhibits the activity of the enzyme, it is known as competitive inhibitor. So let's discuss about competitive inhibitor. So what is inhibitor? Inhibitor inhibits the enzyme activity. Okay, how? Okay, so let's say this is an enzyme. Okay, this enzyme active site was is this one. This is the enzyme, and this is the active site. This is the active site. So in this enzyme, what will be the substrate structure? Substrate should bind to the active site. So let's see. This is the substrate. Okay, now substrate will bind to the active site of the enzyme so that it will process the enzyme activity of okay, it will proceed the reaction towards forward direction. So what is the competitive inhibitor? Competitive inhibitor binds to the active side of the enzyme by a block, and it will block the binding of the substrate. Means what? This the competitive inhibitor should be similar structure, okay, mostly similar structure like the what, like your substrate, I can write it inhibitor. See here, the active site structure are almost same. So the substrate and the inhibitor are structurally almost same. Okay, so the structure, okay, is not exact same, but molecular structure somewhat more resembles to each other. Hence, the inhibitor will go and bind to the active site and it will block the binding of substrate and it will inhibit the enzyme substrate reaction. So statement 2, what is that? When inhibitor is closely resembles to the substrate in the molecular structure and it inhibits the activity of the enzyme. It is known as competitive inhibitor. Yes, so statement 2 is also correct statement. So what is our answer? Option C, you can see here. Both statement 1 and statement 2 are true. Okay? Okay. Thank you, everyone. We'll discuss some more question in future videos. Thank you.